Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Daron Yondem, MVP Microsoft Regional Director at XOGO Turkey, who will be talking to you about Cosmos DB, Jack of all trades, master of many. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC19. Don't forget to check out the Resource Center. This is packed with the latest blogs, ebooks, webinars, and how-to videos. Simply visit SharePointEurope.com and click the content link. Join us at ESPC 19. Call for speakers is now open at SharePointEurope.com. This is your chance to help drive the profession forward. Build your own profile and contribute to the community's success by sharing your experience and insights with your peers. After the webinar, we will have a questions and answers session. Type any questions you have for Daron in the questions window. Some questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you will be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Daron Yondem. Hello, Daron.
Hello everyone. So let's get started. So this is going to be a jam-packed session, to be honest. I'm not going to go very fast though. I will take it slow because, just before the session, we were doing some testing and we noticed that there's 10 to 15 seconds of delay from my screen to yours, the visuals. The audio is fine, but the visual is a little bit delayed. So I'm just going to keep talking, keep your ears busy a little bit so that the visual can catch up. So this is going to be a session essentially for everyone. This might sound like a session dedicated for developers, if that's what you felt the first time you saw the session title, but it's not. It's going to be a session where we're going to have some developer stuff. Obviously, some parts of it might not make sense if you're not a developer, but it's not going to be more than, I'm hoping, 20 or 30%. So the idea of this session is simply, trying to understand what this thing is, what Cosmos DB is, and what's different with it. Why there is such a thing out there that we can, that we can potentially use, or Microsoft wants us to use, and that's the whole purpose of this session. So let's start with a little bit of a history, because when we talk about Cosmos DB, even if there has been a couple of years, the name is out there, it feels like it's something new, which isn't necessarily true. The first time this concept came out, and the concept that the thing I'm calling the concept is essentially NoSQL. And if you go back in time, there was, around 2009, 2010 is when actually people were asking Microsoft to come up with a NoSQL solution. A product or something that that we could use, because back in those days Microsoft didn't have any NoSQL offering, and we had to go out there and find something that we could integrate potentially to a .NET project or whatever we are working on. And 2010 is when this Project Florence was around, and Microsoft internally was using the Project Florence to fulfill that requirement, right? The requirement of having a NoSQL storage that can scale and that can replicate across multiple geographies. Remember, those are the years when,
Hi, Daron, hi. It's Shane here.
Sure.
Can you just try talking a bit gently, because the microphone seems to be very sensitive to your voice, so maybe just kind of... Yeah.
Sure. Okay.
There's a few people just saying that the quality is a bit poor, so maybe if we can just just talk a bit gentler and it should be fine. Thank you.
Okay, I will calm down. I guess I'm used to, shout out loud in, big speaking rooms and conference rooms. I guess that's the thing. Okay, I'm gonna calm down. Is that better right now?
Perfect, Darren. That's much better. Thank you. You're so used to talking to a crowd where you have to like shout out. So it's
Yeah, exactly. I'm in a single room here, and I'm essentially, yeah, shouting out loud.
even
Okay,
a whisper is better. There you go.
okay,
Thanks, Darren.
this is
Take it
what.
away.
Okay, yeah, I will be careful. So what was I saying? Okay, those are the years when think from Microsoft's perspective, they have. I mean, the first thing that comes to my mind is Xbox, right? There are games. And the imagine the back end of all these games and all the projects that are essentially moving from on-prem to cloud, and all these projects. Even it's I mean, SharePoint Online, Dynamics CRM, or Xbox games. Everything has been moving to cloud, and you need a NoSQL store, and that wasn't just our need. It was it was the need of of the teams that build stuff within Microsoft as well. So that's where Project Florence came up, and then what we had is DocumentDB, which is a shameless plug here. These are during the DocumentDB days, I had the chance to work with the product very close during the private preview days. And I had some, I had some press coverage as well, luckily. So it was around 2015 when DocumentDB came out. And as the name suggests, it's a document-based, NoSQL, right? There are different types of NoSQLs out there, and this is just document database. And this is a service that you could go and log into your Azure portal and get a service instance for yourself and start using it. The reason I'm kind of trying to underline the fact that it is a service is because it's not a piece of software that you can download and install on your on-prem server or anything like that. So it wasn't a shippable piece of code, but instead a service that you could use if you didn't need a NoSQL solution for your cloud apps, and that was the idea. And then Cosmos DB came out. Cosmos DB is essentially, I'm not going to say the same thing, but it is kind of the same thing. It's just a name change because there are very valid reasons behind that. But during 2017, what happened is it was during Build 2017, actually, during the Build conference, overnight, every DocumentDB service instance out there, on the Azure portal, overnight, their name changed and got Cosmos DB, the new name. So if you have been using Cosmos DB before 2017, during the Build conference overnight, the service that you were using, has changed and it started being called Cosmos DB on the Azure portal. It was visible as a Cosmos DB service. So the reason behind the name change is that Cosmos DB came up with different APIs during that time. So during the Build conference, Microsoft announced that it's not just going to be a document database, it's going to be a NoSQL database that is multi-purpose that can serve multiple API set, and we will dig into these, what that exactly means. But long story short, Cosmos DB isn't just a document database anymore. It's a graph database, it's a document database, it's a key value database, it's a NoSQL solution that can deliver you what you want. And at that point, it doesn't make sense to call the product a document database, right? It doesn't make sense to call it DocumentDB anymore. So you need to have something more generic. And that's why the name change came up. So, and if you look at this picture, this is, the product that we're talking about today, 2019, is a 9 years old product. Either it was publicly announced or not, either it was used within Microsoft or outside, but it's been a product that's been used in production for 9 years. So sometimes when I talk to people, there's this joke around. So if there's something released from Microsoft, you should wait for the third version so that it gets stable. So we already passed the third version. So we already have a product which is very stable and mature. So. And this is the big picture. Before we dig into into every piece on this slide, this is the big picture. What you have here is that you got it's a NoSQL database which can talk to you in different ways. You can have a table API. You can have Cassandra SQL. It's still supported. It was one of the first API sets that was working on DocumentDB anyways. So you can query your NoSQL data store with T-SQL commands Obviously, there are limitations. You can't do everything that you can do on a regular SQL database, but being able to use the SQL language, at least to query something, get some results, it's good. It's good because that's what our developers know, that's where they come from, and that means they're going to be able to onboard on top of a NoSQL product easily. The same can be said with MongoDB as well. So there's a MongoDB API, there's a Gremlin API, and those are just languages you can talk to Cosmos DB. And obviously, when some of these languages are very specific, some NoSQL types. If you go one level down, you can see 4 different NoSQL types that Cosmos DB supports. Key value is essentially the table API. Column family, document type, and graph. Graph essentially maps with Gremlin. So when you create a Cosmos DB account, what you do is that you select, first of all, what type of NoSQL database you want, and then you select the API, the language that you want to use to talk to that database. And from that point on, you can start building up your application. And the underlying product is always the same product. It's always Cosmos DB, and there's a lot of shared logic across a lot of these, API sets and data structures. So let's step back for a moment, right? So you want to play with it right now. Obviously, it's just JSON, right? So if you go to this URL right now, documentdb.com/SQL/demo, you're going to have a simple data set that you can start querying. You can write queries. If you're curious about, what type of T-SQL queries I can run against the data set, this is a playground. You don't need to get a Cosmos DB service account or anything. You might not even have an Azure subscription. You don't need anything. It's just a playground. You can just visit right now and start playing with it. And the result will be always a JSON, data set that you're going to have, and then you consume it the way you prefer. The other big advantage of Cosmos DB is one-click global replication. And to be honest, it looks like I need to refresh this screenshot because this is a little bit old. So you can have as many regions as you want. It's just, you click it, and there's a save button on top of this screenshot that is supposed to be there. You select the region and click save, and that's it. It takes from 1 to 5 minutes, depending on your data size and the consistency levels that you picked for your collection. And you are done. Your data is replicated. You got endpoints for that, data center. Failover will work if something bad happens. If you got an application, for example, you got a mobile app that is distributed globally. If you're using the Cosmos DB SDK, it will automatically connect to the nearest location. You can override that. You can decide how your app will react. Maybe you want to have some kind of a prioritization, hard-coded within your app. That makes sense. You can do that as well. But the idea is you're not setting up, the way you set up replication is simply 2 clicks, and that's it. There isn't anything much else to say about this, to be honest. It's crazy simple. If you have ever set up a cross-regional database and replication, and we'll go into the consistency topic in a little bit and try to mess with these different consistency levels, it's not easy. It's not easy. I mean, right now it's just a couple of clicks. It's a ring 0 service. What that means is, if there's an Azure data center somewhere, there is Cosmos DB in it, which means a ring 0 service means that the data center itself, for Azure to function, Cosmos DB is required in a data center. So you might have seen some services from Microsoft that might not be available in every region. It's not going to be the case with Cosmos DB. Cosmos DB is available in all regions. It needs to be there. When there's a new data center, it needs to be there. Like I said, you can define priorities for regions, and you can have multi-master, which is relatively new. I'm not exactly sure. It's been 6 or 9 months. Maybe time flies and it's been a year, but it's relatively new. In the past, you might encounter some old articles when you do some research. What you're going to see is that there was a single write region, and you had an n number of or x number of read regions, and that's how the global replication work. You could still have consistency levels set up, the 5 different consistency levels that we're going to talk about. You do have the SLAs that we will talk about, everything, but the write region was always a single write region, and it was a showstopper for a lot of projects. I mean, there were workarounds. Like you could have multiple Cosmos DB accounts having write regions in different geographies, and then combine the reads and writes. Whatever, let's not go into that. It was a messy workaround, to be honest. But today we got multi-master, which means you can go to any region, the closest region or whatever you want based on your preferences. They're all read, write, and they will all synchronize. So locally, you will still have the replicas within the region itself. You will still have replicas. Depending on the performance that you need, you will have read or read-write replicas. You will have master and replicas within a single region, but every region itself will support read and writes. So that's the important thing here. Every region is now writable. Single-digit latency for 99.39s. Consistency levels, we will talk about it. We got 5 of them. You can pick based on your requirements. And consistency, picking the right consistency level isn't always a performance issue. Sometimes it is, but in the case of Cosmos DB, things are a little bit weird. We will talk about how Cosmos DB billing works, which is interesting. But think about it from this perspective. If you want a lot of consistency, you're going to need to pay for it not in the context of performance, but in the context of money. So you will pay more if you want to have higher consistency. You're not gonna pay it in the terms of performance. You're not gonna lose performance if you want a lot of consistency. If you want a higher consistent level and still have the same performance, then you're just gonna pay for it, and you will still have the same performance. So that's that's not something we're used to usually. So because that's the different perspective when you start playing with Cosmos DB. Conflict resolution, you can implement your own conflict resolutions, or there is a couple of built-in conflict resolution policies as well, and unlimited scalability goes with it. So let me jump here. So in order to add multi-master support, it's still optional. When you create a Cosmos DB account, make sure you select multi-master enable. Same goes with geo-redundancy as well. Maybe you don't want to add it, but it comes enabled by default, but the multi-master doesn't come enabled by default. And this is the screen that you're going to see when you go to the Azure portal to create a new Cosmos DB account. Let me slow down here because, again, I remember about the 15-second latency that you're going to see. When you go into the portal again, this is another screenshot where you can, enable reads and writes for every region if you want to, or simply remove regions. So you might see on top of the screenshot, you can see the manual failover and automatic failover. Manual failover means that you can do your testing about, you can have an app using Cosmos DB and you want to do a test of manual failover. So that's something you can do on the Azure portal. So in your apps, when you start writing your apps with C#, first off, make sure your connection policy is correct. So my suggestion is TCP direct. If you can, if your application is working in an environment when this is allowed, I suggest a direct connection. Make sure you use multiple write locations as true. Otherwise, it's going to take a single, a single data center, single region based on your preferences, region preferences, and send all of the writes to that particular region. You can customize the order of the regions you want to add. That's what this the for loop and this code is doing. And finally, you're creating a client, document client, to talk to your Cosmos DB account. Yep. Okay. So Flexible conflict management. So in this case, we got a conflict, and in order to resolve that, we got a couple of options. First off, the default mode is the last writer wins. You can define a custom function, a procedure, essentially, within the Cosmos DB service account to fix all that, or only available for the SQL mode. You can do it in an asynchronous way. So here are some more details. So here what we have is that we got on the right-hand side, we got last write wins, and then we got a conflict resolver property. So this is a property in your JSON schema. You need to define it. You decide what field is going to be used as the conflict resolver, because the last writer will win. In this case, on the left, we got two documents, right? We got the document that defines, the address and the entity for Scott Guthrie and then Satya Nadella. And then we got user-defined ID 3 and 4, which means, last writer will win, and that's going to happen. User-defined ID 4 will win in this case. If you pick merge procedure, then you're gonna have this option where you can give a procedure name and then decide within the procedure who is going to win. The default logic is, again, using numeric numbers to resolve conflicts. Can be user defined, or in our example, when I switch back to the demo, you will see this property called, this field called _TS that might be used as well. That's essentially a timestamp. And this thing is available for all data models. So what about the custom store procedure concept? You give the name of the store procedure, right? And that's the one that is going to be called. That's how you sign it. It has a special signature for it. So I have that in this slide deck. Yeah, there we go. So this is an example store procedure. You get the incoming document, you get the existing document as a parameter, and then you decide what you're going to do. Let me give you a couple of seconds to digest the content here, and maybe some help for the 15-second visual delay. Okay. Sorry. Okay. If you leave let me go back here. You select custom and leave the store procedure blank to do custom asynchronous conflict resolution. Okay. And you handle conflicts within your app. And this is an example C# code that does that. In the response from the Cosmos DB API call, you will get a conflict and you will decide how to fix that within your client app and then report back. You actually get conflict reports and delete conflict reports, and between the two you are expected to fix the conflict. Okay. So what about this SLA that we're talking about, the performance SLA? So the whole idea is whatever you do, it doesn't matter. Consistency levels, the number of indexes you want to have, and the complexity of your query, except store procedures and a couple of other parameters which should be part of another slide. But whatever you do, that's the idea. You will always get 2 millisecond, a maximum 2 millisecond reads, under 6 milliseconds writes for the 50% of the time. And you will get reads under 10, writes under 15 milliseconds, 99% of the time. Okay. So that's the idea. And in order to accomplish that, if Cosmos DB requires more power in the context of CPU, memory, I/O, or whatever you can imagine, that power will be served, and we will pay for it. And that's where we come to the concept of request units. And by the way, just another note, every data that you put in Cosmos DB is indexed. Every field, there are no exceptions. Every field, every property, whatever you call those, every data is indexed on an SSD storage. Obviously, latency is affected by the amount of data that you want to read, but the execution time for the query will guarantee the SLA for sure. The indexing is synchronous. You can make it asynchronous if you want to, but indexing is by default is synchronous. The index management is not required unless you want to save money. You want to disable indexing for some of your fields, which is a good performance trick. Not necessarily a performance trick, but money-saving trick. There is no schema versioning, which means everything works on the fly if you're changing your schema. No schema migration needed is what is being messaged, but sometimes you might need because you don't want to end up with dirty schema. Let's say you're changing the name of a field, right? And you had a bunch of data in all the documents. If you go with the document SQL approach, document NoSQL approach, you got a bunch of data with a particular field, and you decided to rename the field. You come up with a new field name, and what you're gonna end up is a collection with which a bunch of items with the old field name, and then the new items with the new field names. There's definitely some migration that needs to happen, and the idea of no schema migration needed is that your queries will still run. You don't need to migrate your schema to introduce changes into your schema, but most of the time I say you're gonna need it. Let me jump this. Oops. So provision throughput, the request units. How does this whole thing work, and how am I being charged, right? So let's look into that. A request unit is the charge unit, is the currency we pay for whatever we use in Cosmos DB. In a request unit, oops, just a second. Okay. And obviously not all requests are equal. A request unit defines a combination of all of the underlying resources we need to execute a query: the CPU, the memory, the IOPS, everything combined and normalized in a single unit. And that's what request unit is. And every time you send a query to Cosmos DB, you get a request unit back. You get the cost back. This is this is a very simple calculation how it works, but keep in mind these are simple reads, reading a single entity, right? For example, if you read an item 1 KB, 500 reads per second and 100 writes per second, this is going to cost you 1,000 RU per second. So the data size is important. In this case, the complexity of query is not factored in, because the idea of this sheet is that you are simply selecting a single item by correctly identifying and querying it by its unique identifier. Just getting an item, not necessarily querying. I mean, it's a query as well, obviously, if you're reading an item, but this is a simple read. That's what I'm trying to say. This isn't like filtering millions of collections and finding a single item. This isn't that. So you can always go to this website, documentdb.com/capacity planner, to dig a little bit more into the calculations. But my suggestion is, it's tough to calculate. My suggestion is to build something and put some load on it and see how your application reacts against Cosmos DB and how much load it creates. Keep in mind that everything that you do, every piece of code that you do, your architecture, your design, everything affects drastically the amount of consumption that you're going to have. I mean, this is both very good and very bad, because if you are leaving everything loose, then it might cost you a lot. But if you optimize everything, then Cosmos DB might be really cheap. Most of the time, if someone is complaining that Cosmos DB is expensive, there's a big chance there's something wrong with either their partitioning strategy or their client apps not using the right querying strategies. So here's an example. Star from C, a simple select all, and this costs 2.87 RU. Because the reason I'm putting this slide into my deck is that when you first talk about RU and we talk about selecting a single item and so on and so forth, you get the perception that, oh, it looks like the simplest query will cost 1 request unit. No, I mean, this is a select star, which means, I'm not sure what was the case in this particular one, but, depending on the amount of data that you query, the size of your entities, the size of your documents, this will cost more than 1 request unit. So even if this query looks very, very that simple, this is going to cost more than 1 request unit. So here's another one. Select star, and this time we got a contains, right? So this query looks a little bit more complex, right? I mean, there's a contains, there's filtering, and here we go. This one costs 2.45. And the whole purpose of this slide is to confuse you, to be honest, because you shouldn't go with. I mean, you shouldn't trust your gut, and you shouldn't try to estimate based on what you see in a query. Instead, you should simply run it against your data set, and your data set hopefully should be a good representative of what you're going to have in production. That would be an ideal case. And if you go into the Azure portal, on the right-hand side, you see the screenshot where you can simply, write your T-SQL query and run it against a collection or a database, and it simply gives you the request charge on the Azure portal. So it's very simple to test things out. You don't even need to write a client app. If you got your data dumped into Cosmos DB, you can start testing your queries. Okay, so let's do a small demo, calculating RU on the fly. So I'm going to go into the Azure portal here. I already have a Cosmos DB account. Let me go into that. So this Cosmos DB account is replicated across 2 regions. I'm going to slow down again because that delay. So in this Cosmos DB account, I didn't do a lot. I'm just going to go into the Quick Start tab because the Quick Start tab gives you, a nice .NET app, web app that you can start playing with. Usually when you open this for the first time, it says it has a button on the first step that says, do you want me to add an items collection? I already clicked that before our session here. So it did create me a collection that allows me to store 10 gigabyte data. It doesn't support partitioning in this case. You can have partitioned and non-partitioned collections in Cosmos DB. If you're not going to scale and you're fine with the confines of a single partition collection, then you can definitely go with this one. The development is easier, testing is easier. Obviously, you don't need to worry about your partitioning strategy, and it's cheaper. So that's what I did. And then you can click this download button and it's going to give you a full .NET solution that you can open in Visual Studio. And I already have it here. Oops, wrong folder. Let me download it again. Oh, it looks like I got it in there. Okay, there we go. Okay, so this is the zip folder. I'm going to extract this. There we go. Okay, so we're in here. This is a simple to-do app. Let me open that with Visual Studio. While it opens up in Visual Studio, let's go into Data Explorer on the Azure portal. In the Data Explorer, I'm going to run a query against this items collection. Okay, let's go into Documents. Okay, it already did. It already did run a select star, query. Cool. It looks like we can change that. Maybe where c.id equals, oops, sorry, is completed should be the field name equals true. And there's only a single document in this collection. Let me see what the field name was. Just a second. There we go. So this is our, oh, is complete. There wasn't a D at the end of the field. So is complete is the field name. So let's change that. We will essentially see the same result. Oh, there isn't one that is complete. So let's send false. Is complete equals false. Come on. What I'm doing wrong? Okay. There we go. Capital I was the evil. Okay, there we go. We're running queries here and be able to see the results. That's good. Did Visual Studio open up already? Okay, there we go. So this is a simple solution that is connected to our Cosmos DB account. If we go into global ASX here, you're going to see that there's, it initializes a document DB repository, which is here. This repository creates a client and then uses it to do inserts and updates and all that type of thing. And when they initialize the client for the first time, which should be somewhere around here, okay, there we go, document client, we need to give the URI for the service endpoint, and then we need to give the authentication key. Both of these, values, they come from the config file, which is in the web.config in this case. And then we need to have a database ID and a collection ID, which are things that we can get when we create a collection. And these are hard-coded within the web config file as well. I can actually show you all of these values. There we go. Endpoint is this one, okay? Auth key is this one, and then we got a database called to-do items, and then collection called list. Sorry, items. You can obviously create these dynamically as well with C#. So let's go and see what the document DB repository does. And here we go. There's a simple get item async. It trees a document. Cool. And then there's a get items async, which is supposed to get a list of items. And as you see, we cannot obviously select star the whole collection. We need to iterate through pages. Those are queries going against Cosmos DB. So that's why we got a while loop here that has that says if there are more results, keep executing the query. Okay, cool. Let's put a breakpoint here. I just want to run this up. Let's see if this works for the first time, and then we will see how we can get the request charge and see how much it costs to run all these queries. Come on. Cold start. Wow, this has been a long cold start. Do I have Murphy on my neck? . Okay, I guess it's happening. Come on. There's definitely something wrong here. Okay, there we go. Okay, cool. So let me hit F10, another F10, and another F10. Yeah, we should have some results. Cool. Has more results is true. So let's hit F10 and F10 again. And we're not going to go through with the while loop a couple of times because we simply have just one document. But when we look into our results, you can see that we got a single to-do item, which is not completed. Cool. Let's hit continue for now and see the application. I'm guessing that the reason this is running crazy slow right now is because I'm streaming. That's the only thing that comes to my mind. Okay, great. So the app is running. We can add more items here. Let's say another to do it, and create. Obviously, we will hit the debug point again, and there we go. So I want to know how much it costs for me to run this query. Okay. So here's what we're going to do. Actually, with every query that we run, we get back a request charge. Let's do this. Response, and here we go. Let's get the response into a variable so that we can access all of the other metadata that comes with it. And let's say we want to figure out the full cost of this query, including all of these iterations that might happen, right? So let's say request charge or total request charge equals 0. And what I'm going to do is simply every response has this thing called request charge. And there we go. We are calculating and adding up the request charge every time we run a query against Cosmos DB. So the idea is, based on this data, you can actually decide how many request units you want to provision for your collection. For this one, we got a static collection which has 400 RUs per second. But you can dynamically decide and send API calls to Cosmos DB to change how much provisioning you want dynamically. In order to be able to do that, you're going to need to know how much request units you're using. Obviously, if you exceed the provisioned amount, you will get a very nice, good error back from the API, and that might be the trigger for you to decide to scale up. But how are you going to scale down? I mean, somehow you need to monitor your consumption. Obviously, you can implement some other APIs to monitor your consumption as well, but this is a good way to accumulate data. So let's run this one and see how much this one costs. So what we are doing right now is a simple select, not necessarily simple, we got it very close. We are only selecting items that are not completed, I guess. Is that the case? Oh, no, this is a simple select star. Yeah, we're getting all of the items. Okay, cool. F10, F10, F10. There we go, and okay, 2.94 is the total request charge. And because we got two entities, it's not going to iterate, and that's the end. That's all of the cost for our queries. So we are paying roughly 3 request units to get our 2 to-do items from Cosmos DB back. So let's go back to our slide deck because we got a lot to cover. So this is the query that I kind of wrote, in our demo. I just wanted to make sure it's part of the slide deck as well because, at the end of this presentation, I'm going to share a link where you can download the full slide deck. So I tried to make everything part of the slide deck as well, so that you can take those away. If you got, a Cosmos DB account, you got a couple of options. A single partition containers can start from 400 and go up to 10,000. You can have partitioned containers. It starts from 1,000 and goes unlimited. And on the left bottom side, the code that you see is actually the code that helps you scale up or down. This is the C# code that changes your provisioned RU on the fly. So you can monitor your consumption and then send a new offer to Cosmos DB to change your provisioned RUs. Okay. And obviously, partition keys are critical. We will talk about those, but partition keys are critical because that's how Cosmos DB can scale your collection. So the item size affects the RUs. The property count affects the RUs because as many properties as you got, so much indexing you're going to end up having by default. Data consistency that affects RUs as well. If you want to have high consistency, then every query will have a higher CPU, memory, and I/O cost, which means RU cost. Index properties, yeah, you can do lazy indexing. It can help with the cost of a query. Document indexing, you can disable it. You can disable indexing all over. I mean, if you don't need it, just disable it because it's going to cost you not only RU cost, but it's going to cost you in the mean of storage as well. And query patterns. We'll not go into the details of these, but if you're using custom functions, predicates, then your query patterns will be complex and it's going to affect your RUs. If you're using store procedures, triggers, then obviously Cosmos DB will need more power to accomplish your query, and it's going to cost more RU in order to be able to hit that SLA. Let's look at the reporting tools a little bit. So this is one of the screens you can see when you go into the portal. What you will see here is, first off, on the left top left would be better. You see the SLA and the actual availability that you have. It looks like we got a higher availability than the SLA. And you can see the number of requests per 1 hour on the top right. Request charge for every type of query that you're sending, right? So this is kind of the overall consumption you can see. But what if you exceed, right? What if you try to use more than you have? Then this is what you're going to have. You're going to have an HTTP status 429. It's going to have a custom header which tells you how much you should wait for your RUs to get back. Essentially, you already use all of the RUs you got for that particular second. Here's the amount of time you should wait so that you can send more queries. You can definitely implement that, or you can go send a new offer and scale up your collection. Let's talk about partitioning a little bit. If you want to have unlimited scale, you must have a partition key. In this example, what we have is partitioning is structured around different airports. Based on your data set, it will be something different. It can be something different. In this case, partition key is the airport field. We got a container. We put all of our data into that, and when needed, Cosmos DB will separate your logical partitions into separated physical partitions. For us, it doesn't. It's not important. We simply don't care. We shouldn't care. That's the idea, right? We should know, and we should treat it as every logical partition is actually a physical partition. That's how we should treat it. But the underlying architecture is going to fluidly decide if a logical partition needs to be a physical partition or not. And every partition will have 2 additional replicas. This isn't something we can manage, and this isn't something we should worry. This is for failover purposes. This is totally managed by Cosmos DB. Yeah, partition schema is immutable. You cannot change it. If you need to change it, you're going to need to migrate your data to another collection, which is a pain in the neck. So that's again that goes back, how critical your partitioning strategy is. So overall, we didn't start talking about the partitions, but what happens is we got data centers, we got regions, we got data centers, and then within the data centers we got Cosmos DB stamps, and then we got fault domains, and then we got clusters, right? Cluster of Cosmos DB instances, and then we got physical machines. On the physical machines, we got the agents that organize things across the machine. How much of it will be for Cosmos DB? How much of it will be for something else? And then we got replicas on the machine. Replicas are managed by Cosmos DB itself, and the database engine on top of it provides, the indexing, query processing, and all that stuff. So this is kind of a very, very high level architecture. If you dig a little bit deeper, what we got here is containers are separated across resource partitions and regions. So every region has a resource partition. Within every resource partition, you got one leader and two followers. One of those copies, the forwarder is essentially the leader, the forwarder, and the two followers. One of those is responsible pushing the update to another region. Okay, all of your reads and writes goes into the same replica set. Writes goes to the leader, reads and distribute. Let me start from scratch. Writes go to the leader, and leader distributes. Reads are distributed across followers and forwarder without the leader being in the middle. So zoom in a little bit. This is the picture. We got 3 regions. Every region has a replica set, and every replica has 3 copies. And there is synchronization going on between all of these regions. So you should read data from partitions. Let me rephrase that. You should never, read data across partitions. You should never query cross-partition data sets, because it's gonna, first off, you're not, Azure will not provide you an SLA. The performance SLA is only available per partition basis. So if you start sending queries that are supposed to run across partitions, then you're not gonna have an SLA. But you can still hit the SLA, and we will talk about it because of the nature of the distributed scale. But let's focus on what we have on the screen right now. So we got a query which has a partition key in it, which is ideal, which is what it should be, right? We are querying a single partition. We got our SLA, we got our performance SLA, and all that stuff, and perfect. But here we got another query which doesn't have the partition key in it. So first off, take a look at the feed options item. So within the feed options, what we're saying is we specifically, say that we're going to run a cross-partition query. If you don't specifically mention that you're going to run a cross-partition query, Cosmos DB will not run this query. The SDK will not run this query, to be honest, because this is simply not allowed, right? You need to specifically, mention that you are, emphasize that you are wanting this query to run cross-partition. Okay. Here's another query. This is an interesting one. This has 3 partition keys. So the beauty of the Cosmos DB SDK is that it is going to figure out that there are 3 partition keys, and it will send the queries to these 3 partitions only. And this is still going to be a cross-partition query, but it's not going to go and hit all of your partitions. It's going to hit only 3 of your partitions, which is much better, and which is going to cost less, obviously. And you need to decide how much of a parallelism you want to have, because when you run a cross-partition query, it's not running, the queries are being sent to all these partitions, and the results are being aggregated client-side. And that's done by the SDK. That's how cross-partition query works. And if you have the right amount of parallelism with the right amount of partitions, then you might still hit the SLA, because every partition will hit its own SLA. If you're running all of them in parallel, then you might still get a result within the confines of the SLA. No one is going to be to guarantee that, because that depends how your client performs and how your client implements parallels, but that's possible. But again, these are all, you shouldn't be in this world. In an ideal world, you shouldn't run cross-partition queries. So what if we got a wrong partitioning strategy? How do we detect hot partitions? Okay, here's an example. So let's analyze a screenshot. On the left top, we got the graph that shows consumed per partition and provisioned per partition. So it looks like our consumption is higher than our provisioning per partition, right? Cool. So let's skip right. So top right. Average consumed RU, it looks like it's lower than our provisioned RU. So this is weird, right? So our average consumed RU is lower than our provisioned RU, but max consumed RU per physical partition is higher. So it looks like the average is good, but okay, the max is bad. There might be, it feels like there's a partition, there's a single partition maybe, that is exceeding the amount that we provisioned, but on average we're good. So our query is hitting that partition will suffer, but every other partition is cool. So yeah, that should be the case. So when we look at bottom left, number of requests per minute, it's all HTTP 200s, that's good. But on the right, number of requests exceeding capacity per 1 minute, we got a lot of 429. So we got some queries that are exceeding the capacity. But on average, we're good. There's the single partition that is having the problem. So when you look into another page on the Azure portal, you can actually look into how much data you got per partition. And this might give another idea, right? And it looks like we got this partition, which is, it looks like this data set is partitioned based on city. Seattle has a lot of data compared to all the other partitions. So this might be a reason. I don't know 100% sure right now, but the data size makes me feel like this might be the partition which is causing the problem. So, and this is where we should start with. We should look into that and we should investigate. If this is the case, this is a hard partition, then we should definitely change our partitioning schema and try to distribute the data set across other partitions. Because the thing is, if you got 50,000 RUs, your RUs will be separated across your physical partitions. So let's say you got 50,000 RUs and you got 5 physical partitions. Even if you had 10 logical partitions, you got 5 physical, because that's how Cosmos DB had to distribute. So 50,000, 5 physical partitions, you're going to end up having 10,000 RUs per physical partition. And if Seattle partition right now, for example, is exceeding 10,000, in order to be able to scale that, you're going to need to scale your full collection. In order to bring Seattle from 10,000 to 15,000, because you got 5 physical partition, what you're going to need to do is to scale from 50,000 to 75,000, so that Seattle partition can have its fair share of 5,000 additional RUs. So it's going to be very painful if the partitioning strategy is wrong. So let's talk about consistency levels a little bit. We got 5 of them. We got strong consistency. We got bounded staleness. Strong consistency, I guess it's something that we all know. Bounded staleness, you can specify a number of versions you can lag behind. That's essentially what it is. Session consistency, I guess that's again a well-known one, a session-based consistency. And the fourth one is the consistent prefix. You can decide how much late you're gonna be in the mean of, you will still have consistent, but you can be late. But the order of the data that you're gonna have is still will be consistent. And eventual consistency, it's again, a well-known consistency level. And this is the set of SDKs we got per API set, just for reference. We got 4 different structures that we support. They're all native. They're all supported. The underlying resource model is projected in different API sets, but the resource model is always the same. That's how Cosmos DB is able to serve those different API models. It's just that the projection changes from API level to API level. Indexing works automatically, but you can customize it. You can customize it based on the data type that you have. Indexing policies are defined as a JSON within the Azure portal. You can enable, disable, and change the precision of an index as well if you want to do that. Okay. Yeah, if you want to lower your cost, you should definitely look customizing your indexing policies, and that's something you can do in C# as well. Just wanted to put out a simple sample code here. And if you, when you're sending queries, if you add this additional attribute saying populate query metrics as true, you can actually get a lot of metric back. Obviously, this isn't something you want to do in production, but this is something you can do when you are stress testing or load testing your app to see what you get out of your queries. So the 4-axis SLA that we talked about, consistency is covered through SLA, availability is covered through SLA, throughput, the performance is covered through SLA, and latency is covered through SLA. And all of that is accomplished through the concept of RU, right? So if you look at from a security perspective, everything is encrypted as REST. You can have IP-based access control, role-based access control. Automated online backups is out there. Attack monitoring and geofencing are available as well. Just wanted to put it into the notes. There are integration options that you can use. Again, just wanted to include these into the slide deck as well. We'll give it a couple of seconds. We're not going to go into the details of these, but just again wanted to include these here. And as a final disclaimer, Cosmos DB is not a SQL database. Do not think about it like from the old days of SQL. Not necessarily old days, but anyways. I hope you got what I'm trying to say. So I hate calling technology old just because it's being used for a long time, because old makes you feel like you shouldn't use that anymore. At least that's how sometimes people interpret, but that's definitely not what I'm suggesting. But it's something different. Cosmos DB is different. You shouldn't think about even if some of the wording sounds like we got especially if you're using T-SQL querying against Cosmos DB, it might make you feel like you're using SQL. It's not. You should try to keep away from that mindset as much as you can. You can definitely use other NoSQL solutions as well. They might be good in one thing or another. When you decide to use Cosmos DB, think about it in a way that it's a hosted service, it's a global database, and it's good at doing those things. It's not going to be good at everything, but it's going to be good at these 2 things for sure, because that is why Cosmos DB is built. That's the reason it exists. So here's a summary, a couple of links. It looks like I'm already over the time for a couple of minutes. So let me jump here. This is an address where you can find workshops about Cosmos DB if you want to play with it. I got a lot of resources in the next couple of slides as well. This is a course from Microsoft, a full course. You can even get, certified, verified certification if you want to. They have a YouTube channel. They do publish pretty cool videos, to be honest. They don't have, it looks like they have, this screenshot is pretty fresh. It looks like they need subscribers. So go ahead and subscribe. And finally, again, another shameless plug. This is a book that I co-authored with another friend, and the PDF is free, thanks to Microsoft. So they are distributing the PDF for this book for free. Go grab it if you want to learn more about Cosmos DB. And there you go. On the bottom of the slide deck, you can see the link where you can download this slide deck. I have added a couple of slides about resources. That might not be there, but I'm going to keep you updated after just this presentation. So that's all we have.
Thank you, Daron. That's super. As you mentioned, Daron, yeah, we are slightly over time, so we're going to forego any questions and we're just going to wrap it up. Is that okay? If people reach out to you, if there's any questions, would that be okay?
Sure, they can always hit me up on Twitter, and I will do my best to help them out.
Excellent. Daron, thank you so much for taking the time to go through your session today. Really appreciate it on behalf of the European SharePoint Office 365 and Azure community. Thank you so much.
Thanks everyone. Thanks for everyone for being here with us.
Super. Okay, I'll just take back control there now. One sec. Okay, everybody, thank you all for joining. And again, a big thank you to Daron for his presentation today. Please see sharepointeurope.com/register-for-webinars for further details on all upcoming webinars, or visit our resource center for all previous webinars. Thank you all for joining us today. Take care and goodbye.